1.1.6 Relative atomic mass. When you look at the periodic table for GCSE, you'll notice that copper has got a relative atomic mass of 63.5 and chlorine has got a relative atomic mass of 35.5. Now this doesn't mean they've got half a subatomic particle, they've got half a neutron or something like that in the nucleus. The relative atomic mass is the mass of the atom, the average mass of the atom, taking into account the abundances of the isotopes of that atom that we know about. Let's consider the example rubidium. There are two isotopes in this example for rubidium. We have rubidium-85 and rubidium-87. And let's say 72% of it has been calculated that it's rubidium-85, which means that 28% of it is rubidium-87. The way we calculate it is this. We take the relative atomic mass of the first isotope, 85, and times it by the relative abundance, 72. Then we add it to the relative atomic mass of the second isotope, 87, times by the relative abundance of that isotope, 28. And because it's a percentage of over 100, we divide the answer by 100. In this example, we get an average of 85.6. Another example you'll come across is this. The most common isotopes of chlorine are chlorine-35 and chlorine-37. So on average, there's 75% of chlorine-35 and there's 25% of chlorine-37. So the sum or the calculation would be this. It would be 35 times 75 plus 37 times 25 divided by 100. And if you do that on your calculator, you'll get the answer of 35.5, which is the mass you'll see recorded in the periodic table. 1.1.7. You already know that electrons occupy the shells or energy levels around the nucleus. And you know that different energy levels can hold a different number of electrons. So for instance, the first energy level can hold 2. Then the second and the third energy levels can hold a maximum of 8. And the fourth can hold, well, we'll say at GCSE, it can hold up to 18. If you go on and study A level, you'll learn about S, P, D and F orbitals within each energy level. But don't worry about them for now. So if we take an element, let's say sodium. Sodium is the common example that we go to at GCSE. The atom of sodium contains 11 electrons. That means if we're filling up the electron shells, we fill the first shell first. So the first energy level can hold 2 electrons. Then there's 9 electrons left for sodium, so we put 8 electrons into the second shell, which means we've got 1 electron left to go in the third shell. So the electron configuration for sodium is 281. Which please make sure you can explain the electronic configuration of the first 20 elements. So for instance, aluminium, make sure you know you can work it out, 2.8.3. Carbon, make sure you can work it out, 2.4.